For more than 4 decades, a small spacecraft no larger than a compact car has been flying outward from Earth. It has not stopped. It has not turned around. It has crossed the orbits of every planet humanity has ever named, passed through the silence of the outer solar system, and kept going. And going. Its name is Voyager1. It is the most distant object humanity has ever sent into space. And in 2012, it reached a place no spacecraft had ever reached before. The edge of our solar system's protective bubble. Scientists expected a gradual transition. Instead, Voyager1 found something stranger: waiting. Voyager1 launched on September 5, 1977, long before most of the people watching this were born. Its original mission was simple: visit Jupiter, visit Saturn, take photographs, send back data, and then end. That was supposed to take about 5 years. But the spacecraft refused to die. After Saturn, it kept going, beyond Pluto's distance from the Sun, past the last comets, out into a region of the solar system so dim that the Sun appears as little more than a brighter star. Today, more than 47 years after launch, Voyager1 is more than 25 billion kilometers from Earth, about 167 times the distance between our planet and the Sun. A radio signal sent toward Earth right now would take more than 22 hours just to arrive. It is moving outward at roughly 17 kilometers per second, every second of every day, forever. And in 2012, it became the first object built by human hands to reach a region nobody had ever directly sampled before, a region we had only ever guessed at. The Sun is more than just a star giving us light. It is also a kind of shield. The Sun constantly streams charged particles outward in every direction, a flow we call the solar wind. That wind blows outward for billions of kilometers, carving a vast bubble around the entire solar system, a bubble called the heliosphere. Inside this bubble, us, the planets, the asteroids, the comets, every object that has ever orbited our Sun, outside the bubble, interstellar space, the medium between the stars, and the boundary between them, the place where the Sun's wind finally weakens and gives way to interstellar particles, has a name: the Heliopause. For decades, scientists wondered what it would actually look like. Would it fade gradually, like the soft edge of a cloud? Would it ripple, like the surface of water? Would it be turbulent, chaotic, hard to even define? In August 2012, Voyager1 finally crossed it, and what it found was none of those things. Because the boundary did not fade, it did not ripple, it did not slowly thin out. It was far sharper than anyone had expected. When Voyager1 crossed the Heliopause, the plasma density around it suddenly increased by around 40 times. Not gradually, a sharp jump, as if the spacecraft had stepped from one room into another and shut the door behind it. The magnetic field around it also behaved in a way nobody expected. The interstellar magnetic field, the field that fills the space between stars, should, in theory, point in a different direction than the Sun's. But Voyager1 found the two fields strangely aligned, almost as if our solar bubble were somehow shaping the field outside it. Existing models suddenly needed revision, and for the first time in history, we were not theorizing about interstellar space. We were inside it. And then, quietly, in the years that followed, came one of the most haunting discoveries Voyager1 ever made. A team of scientists analyzing years of plasma data noticed something they had not seen before. A faint, persistent oscillation in the interstellar plasma itself. Not a sound. There is no air out there to carry sound, but a steady ripple in the medium between stars. What researchers have come to call an interstellar hum. A signal that seemed to be continuously present in the data, year after year. a low background music of the space between stars, picked up by an instrument the size of a kitchen appliance, more than 100 times the distance from the Sun than Earth is, decades after it was built. The universe, it turns out, may not be as silent as we once assumed. We just had to send something far enough out to listen. And then, almost as if the universe was reminding us how fragile this little ambassador really is, Voyager1 nearly went dark. In late 2023, NASA noticed something was wrong. The data Voyager1 was sending back had become unreadable. Streams of meaningless characters, as if the spacecraft were speaking a language it had forgotten. Engineers traced the problem back to a corrupted memory chip on a computer that was already nearly 50 years old, designed with technology few engineers still work with today. To fix it, NASA had to write new code, move it around the damaged region of memory, send commands across more than 25 billion kilometers of empty space, wait nearly a full day for each instruction to arrive, wait another full day for each response. And then, astonishingly, it worked. By mid-2024, Voyager1 was speaking clearly again, a spacecraft from the 1970s, repaired remotely. From a distance no human will ever travel in a lifetime. It was, in many ways, one of the most quietly extraordinary engineering feats in the history of spaceflight. But Voyager1's power is fading. Its electricity comes from a small nuclear generator that produces a little less energy every year. To keep the spacecraft alive, NASA has been switching off instruments, one by one, extending its life by trimming what it can do. In a few years, sometime in the late 2020s or early 2030s, the last instrument will go quiet. Voyager1 will stop transmitting. We will stop hearing it. But the spacecraft itself will not stop. It will keep moving outward, silent, dark, intact, for billions of years. In about 40,000 years from now, Voyager1 will pass within a few light years of a faint star called Gliese 445, a star almost no one on Earth has ever heard of. By then, we may be a different species, or no species at all, and Voyager1 will still be flying. So, when we ask what was waiting for Voyager1 at the edge of the solar system, the honest answer is this: a boundary of plasma we had never touched, a magnetic field aligned with ours in ways we did not expect, a faint hum in the medium between stars. And beyond all of that, a darkness so vast that our entire solar bubble, with all its planets and all its history, is barely a single drop in a much larger sea. Voyager1 was the first to step into it. It will not be the last. But it will, almost certainly, be the most stubborn. A small machine, launched by a species that had only just learned to fly. Still going. Long after the people who built it are gone.